Let's start with the second part of the introduction to the differential equations. Okay, wait for a while, let me check it. Okay. It is fine. So first we will discuss that the differential equation of first order and first degree differential equation. I think you are familiar with the terminologies first order and first degree. This means what? This means what? That a differential equation containing dy by dx to the power 1. This means what is the order of this thing? The order is 1. What is the degree of thing? 1. This is the degree. So for solving first order, let me write it. For solving first order, first degree differential equation, we have various methods. In which we will first talk about, today we will talk about the separation of variable method. Separation of variable method. Okay. If you are studying in graduation first year, then you will surely read about this. Okay. Let me clear it. Sometimes in examinations like GATE or JAM, there you may encounter some questions related to direct separation of variable method. Okay. So what is a separation of variable method? Say you have a differential equation. Say if you have a differential equation, what look like this? Okay. Say dy by dx is equals to, say, f of x by g of y. This is what is f of x here? Function of x. And what is g of y here? I have written g of y. You may write f of y. This is the function of y. Okay. Now what you have to do in case of separation of variables, that you have to separate the function of y each the function of the functions of y in one side and the functions the function of x in the either side. This means what we can do from this in the above mentioned differential equation. What you can do, that you can see this gy is in the denominator of the right hand side, and in the numerator of the left hand side there is a dy. That means you can easily write by cross multiplication that gy dy it becomes fx dx. Okay. Now what you have to do now, this is the, you can write this as step 1, that is separate, and step 2, in step 2 you can write now integrate. How to integrate this? Right, just integration sign, give integration sign. Gy dy is equals to integration fx dx. Okay. If there is, I am writing, if there is limit given, then put the limit. If there is no limit, in the second point, in this point, in the second point, if there is no limit given, then write constants, write constants. Okay, this is the basic formulation of separation of variable method. It is one of the easiest possible ways of from which you can do differential equation solve. Okay, therefore let's take an example of separation of variable method. Say, no, sorry, I am giving a question. Okay, what is the question? Solve the differential equation. Solve. Okay. Say e to the power y plus 2 sin x dx is equals to e to the power y cos x dy. This is the differential equation given. Okay, this does not looks like the conventional differential equation. You have to make this a differential equation by putting by cross multiplication. Okay, you can, what is the answer of this? Okay, writing the answer, what will be here? E to the power y plus 2, say e to the power y plus 2. You can easily check this fact that if you put this dx on this side, on the denominator of dy, okay, then this will be a differential equation, so we do not have to write specifically the differential equation. Okay, then use separation of variable first. In this term you can say, you can see that there is a, this is a function of y here. Okay, e to the power y plus 2, and this is a function of x, this is dx. Therefore there is a inhomogeneity in this site. Okay, this means this contains function of y's and then function of x. Therefore what you have to do, you have to do step 1 first. What are the step 1? Step 1 means separate the variables. Okay, what are the variables here? You have to separable in case of say sin x dx by put this cos x on the left hand side, cos x. In this right hand side, what will happen here? E to the power y, e to the power y plus 2 dy here. Okay, now separation of variable, I think separation of variable is done here. Now step 2, what was the step 2? That was integrate. Integrating this we get sin x dx by cos x. You can write it like this, and also you can write a uy plus e to the power y plus 2 dy. I think this is okay to you. Therefore what you can do here, you can write, you can do it in your own, that the differential equation, this is the differential. Okay, you can say I am just doing this for your purpose. I can easily see the derivative of cos x. The derivative of cos x is in the above. Okay, so I can easily write it as d of cos x, giving a minus sign here. But I am not doing this. I am doing in the more general way, in the more simple way. Okay, say cos x equals to t. Therefore differentiating this, what we'll get? Minus sin x minus sin x. Here it will come a dx, and in this side you will encounter a dt. Okay, so sin x dx will be what? Minus of dt. In this side you also can do one thing, that say e to the power y plus 2 is equals to a variable. Say, what is the variable? Say u. Therefore differentiating this, what we will get? E to the power y plus 2 is equals to du. Okay, now what we will get from this? The ey will be differentiated by this d factor. What will becomes? It will becomes e to the power y, and and differentiating 2, what we will get? 0. Okay, e to the power y dy equals to du. So now from the above mentioned integration, okay, what we can say from here? Minus, putting the value of sin x dx is minus dt. Take the minus sign out of the integration, and what is cos x? Cos x is t. Okay, in the right hand side, what we can do from this? This is uy dy is equals to du by uy plus 2 is what? 2. Okay. Now solving this, we get minus ln t is equals to ln u. As so you can take the constant as, see, now what you can do from this? Minus lnc. I am taking minus lnc for simplicity. Why? You can take anything. You can take anything. Okay, so what will become here? Take the ln u on the left hand side, that ln t minus ln u is equals to minus ln c. From this you can write ln t plus ln u is equals to ln c. This means this will be what? Ln t and ln u becomes ln ut or ln tu is equals to ln c. This means ut becomes c. What was our u? U was e to the power y plus 2, and what was our t? T was cos x, and in this side you have a constant. This is a solution of the differential equation. It is easier if you practice this, then it will be more easier. Okay, this is the required differential equation. Okay, sorry, this is the solution of the differential equation. This is the solution by separation of variable. Separation of variable method. Okay, I think now this is clear to you. So I am giving a homework to you, that the separation then in say question. If it is possible to give the answer on the comment box, then please comment below. Okay, what will here come here? E to the power, say question, dy by dx is equals to e to the power x minus y plus x square e to the power minus y. Solve this. Question is, solve this differential equation. I think it is clear to you, and now you can do it by your own. Okay, so thank you. This was the second part of the differential equation. I have to merge this video with the previous one, but I am giving this video separately. Okay, because this is separation of variable, and this is a method of solving differential equations. Hence I do not I should not include this video with the conventional introductory part of this differential equation. So I have made the video in a separate base. Okay, so thank you. Like and subscribe the channel and share among your friends.